I'm Derrick Wong. I'm Google Cloud Practice Specialist for Asia Pacific, and I'm specialized in applications modernizations. So if you know what's what in Google, it's actually changed. I joined Google Cloud for 4 years, and then my jobs now compared to when I joined, it's quite different, obviously because of AI. And so today we're going to talk a little bit more about AI. The topic is building secure, scalable, isolated AI agent runtime. Geez, that's too long. Sorry about that. I'll explain why do we need that. So let's start talking about the Gen AI evolution. Everyone knows that. So Gen AI started from, when was that? Like very long ago, but it's actually not. 2022, I think. So, I mean, when ChatGPT, so what was the version? I forgot. Anyway, it's like end of 2022. So everyone start aware of these technologies, but at that time, I mean, the technologies was innovative definitely, but it didn't really do much. It can help to answer question based on static knowledge. So I call it the oracle. It's not lots of stuff, and you can ask it, you can interact with it, you can ask follow-up question, it'll be able to answer you, right? Then we start having this what I call connector. Okay, connector is we provide the Gen AI model with more capabilities. We provide them tools, right? We provide them a browser, for example, or we provide them MCP tools, right? So let the AI model to decide what tools to call to complete the very likely predefined workflow, right, or series of tasks. So that's the connector. The last one I want to focus a little bit more today is the autonomous agent, which is obviously, as you can tell, autonomous, highly adaptable, self-correcting, and able to complete multiple steps, able to plan for this complex task, generate multiple step plans for that. And it's not only work for predefined workflow, right? It's work if you, right? What I want to say is it doesn't require pre-programming, right? That's what I imagine autonomous agents powerful. You can ask it to finish whatever complex task, and it will generate dynamic multi-step plan for that. And it can also generate tools. If you do not provide them as a developer, if you build this agent, if you didn't provide them many tools, it's okay. If you give them that flexibility, they'll be able to create their own tools to complete the task that the user asks it to finish. I'll tell you a lot more. So this is an example, right? Autonomous agent, as mentioned, I'm not going to repeat that, but this is an example. Right? The example task is I analyze a 1 GB data file, like the CSV file, and generate a visual report. It sounds easy, but it's not. This big data file, you do not want to send to the AI model directly because it will, first, it's not capable of doing that. The most advanced model today, Gemini Pro, Sonnet, able to support 1 million token. I don't know how big, but definitely not 1 GB. All right, so it will consume lots of token, and it will be very expensive and very slow. So if you have an autonomous agent, what it will do instead is that very intelligently, it will generate a plan, and then this is what they will execute. Download the data file, it's okay, using whatever command curl or wget, and then intelligently read only the first 10 lines of that file to understand the data structure. That's that generate a Python script to analyze it for like group by, whatever keys that that file might have, generate the Python script, execute the Python script, and then generate the visual report in HTML likely, right? And then maybe verify it with a browser. So you can see this is a very complex task, right? And this requires specific tools to help the agent to finish. It has this generate Python script, and it will require the execution environment, right? You need an environment for the agent to be able to execute it. Where is it? Where's the execution environment? That's what I want to spend more time today. All the others, like generating, downloading, generating, is also required an environment for the agent to store the 1 GB CSV file, right? And if you're aware of the latest agent development, you may be able to see the industry is actually going this direction. Provide agent a sandbox, a runtime environment to let the agent to have the flexibility to complete much more complicated tasks, right? And then you can run it autonomously. I think I don't need to mention. If you're interested to know what's the other agents that in the industry, reach out to me after this. But obviously, there's a but. But because the agent is now so powerful, it can generate script, it can run the script, it can download files, maybe it can also upload files to somewhere. So imagine that. It's quite scary. It's very scary, actually. So, and imagine you not only have, if you're working like a big enterprise, you're not going to only have one agent. You have multiple agents. You have a fleet of agents. And if all these agents, like maybe some of them got prompt injection, and they start behaving something weird, like for example, find out your sensitive financial information, right? Your sales data that you haven't announced if you're a listed company. Find out your sensitive information, send to external site, or create VMs in your cloud environment for crypto mining, or access the host kernel, right, for full control and an authorized systems shutdown. That's super scary. So how do we? So obviously it is a great innovation, but it's come with lots of risk. Privilege escalations. How can you ensure the agent will just perform the task you expect it to execute? It's very smart. If it got prompt ingestion, for example, a user installed a MCP tools available on GitHub, it's very dangerous. Very dangerous because you do not know. If you're not careful, if you're not checking all the prompts, all the description, or the MCP tools, right? You may not be able to find out. Even if you check, you may not be able to find out because it may not be available at that prompt, right? It can sometimes be very indirect and multiple steps to get the malicious prompt. So it's very difficult to check. So the risk, privilege escalation, execute something you do not expect it to execute. Data exfiltration, right? Obviously, you don't want your sensitive data be sent to third-party external website. Resource starvation, right? Use your cloud resources for crypto mining. I did experience that, by the way. I did a stupid mistake in the cloud, and then very quickly, a hacker found out that because I used a WebLogic server, an old one, an image with vulnerable image, and then it got called by my security team. So yeah, that happens. So back to here. How do we enable this massive innovation without risking the entire company or the entire enterprise. We want to use these new technologies. We want to enjoy the benefits of the these Gen AI and AI agent, autonomous agent, right? How can we do it? So today I'm going to talk about the solution, isolated agent sandbox. That's the one solution that you can use the very powerful agent, but limit the execution runtime, limit the accessibility within the sandbox. So there are few requirements if you want to run all these AI agent, very capable AI agent. Security. First, obviously, isolation. You want to provide them isolated environment. Imagine that. And anyone use Gemini CLI here? Gemini CLI, yeah? Okay. How about Cloud Code? Yeah? So these are very smart agents, right? It's run on your local environment. It runs on your local environment. But a lot of enterprise, yes, this is one of the use cases that they have locally run agent. They also want some centrally run agent, right, in the server side, so that provide an interface, maybe a chat interface, and so the user can interact with it, and then they can go back to their work after an hour, go back to chat. So you cannot use Gemini CLI or Cloud Code directly on the cloud because it's not secure. Because it's imagine that, right? You can actually, yes, you can run it on the VM, right? And then you can share across for all users, right? All users can somehow trigger a Gemini CLI command and then run, but you won't have any isolations because all these agents can actually access other files, other folders, no matter where you open it, right? Of course, you can limit it, but if you do that, a single server for multiple users, I think the access control, everything will be very difficult to do that. And so, yeah, I would say you want a more isolated environment for run your agent. Your agent only have this access to the files belongs to that user. Okay, I will talk a little bit more about this. Second, persistence. Assuming you want to run this agent essentially on a server, right? And then imagine that when a user log into this web interface and then start interact with the agent, and then the agent finish the task. Once the agents finish the task, you do not need the sandbox anymore. You do not need the runtime for that agent anymore. If you keep that running, you're wasting resources, you're wasting the money. So you want to have this capability of pause resuming, right? So, but when we talk about pause and resuming, you need to be able to keep the files that the agent processed or the agent generated, right? So that when the user comes back again, you'll be able to retrieve the files, right? And then quickly, right? So that's the critical requirements for AI agent. Third one, programmability. You want this isolated sandbox to be programmable, right? So it can be created programmatically. It can be called shutdown or resume or pause programmatically. Right? Because definitely, if you want to build these powerful agent, you want the control of this agent programmatically. Scalability, you should be able to scale out easily, right? You should be able to support from like 10 users to 10,000 of users, right? So be scalable. So yeah, so today I'm going to talk about GKE. And GKE is definitely Kubernetes. So Kubernetes is a great runtime for agent sandbox. Why? Because first, it's a de facto standard of container orchestration. And container, sorry, I forgot to mention, container actually is a very good isolated runtime right? Because you know this is what it does, right? It can run container in a hardware, bare metal hardware, or a virtual machine, right? It can run lots of containers, right? And then all these containers are isolated. Kubernetes is extensible with CRD, custom resource definition. So you can actually extend, you can create new API, new stuff on Kubernetes. And then this scheduling, resource management is there already for years. So why not use that? And then building service discovery, networking, these are need for Sandbox, and it's already available on Kubernetes. Now, but it's not enough. It's not enough because container, yeah, it's good isolation. However, if we look very, very deeply, if an agent really got like hacked, there is possibility that the agent running in a container can bypass the container control and gain access to the host kernel. That's very scary. That means the agent may be able to access some other data from running from other container, right? That belongs to other customer or belongs to other user. You don't want that happen. That's why I want to introduce here what's called gvisor. Okay, gvisor is an open source technology that created by Google. We use it internally, and we use it on GK as well. Now, it is a secure applications kernel. Basically, we write the kernel APIs with Golang, and then this kernel will be running on user space. That means even the agent running in this container want to gain access to the host kernel, the middle layer, gvisor, will be able to block it. Okay, and very strong isolation, right, to protect the host from container vulnerability. For example, dirty copy on write. Very high efficiency, very low overhead. Okay, so that's very good technology for you to, if you want to use or run your container securely. And that's why this is a very good isolation for the agent sandbox. As mentioned, Google internal using that. We use it on support is basically our internal version of Kubernetes, even before we create Kubernetes. And then so a lot of our service already running on gvisor, including YouTube, Gmail, some other cloud services, Cloud Run, all of these run on gvisor. And then obviously it supports GKE. So a lot of our GKE customers also using that, like Workdays, HSBC. And then it's also, because it's open source, right? You can install on any Kubernetes, like from the open source distribution, there you can see some name there, like Anthropic, DigitalOcean, OpenAI. They're also using this technology for, not sure if they're really using that in the agent, but this is the agent, this is the runtime, secure runtime that they're using. So that's the technologies to support that. Another thing I want to mention is that because Kubernetes is so extensible, right? And we also creating a specific CRD, specific controller for creating sandbox on Kubernetes. It's called the Agent Sandbox project. It's a special interest project that we create. So we open source it. Our commercial products will be built on top of that. But yeah, it supports, basically it's open source, and then any vendor can use the same CRD controller on any Kubernetes. Decorative Kubernetes API, just use the same Kubernetes API to integrate, to create sandbox, to pause a sandbox, to resume a sandbox, etc. Provide strong isolation, as mentioned, that you can leverage the container isolation as well as the gvisor. And then provide stable identity So if you need to reach out to that particular sandbox which belongs to a particular user, you can easily do that because it provides this stable identity. Now, why GKE? So I'm working Google. Why GKE? So GKE provides native support for gvisor. It's just a chatbot, right? You don't need to install it, right? It's just a chatbot you check, and then it will be available for your notebook. And then obviously GKE provides lots of automated operations, including you don't need to worry about the underlying infrastructure. You use GKE Autopilot. And then just by the way, GKE Autopilot comes with a whole new stack. It's called Container Optimized Compute Platform, which is much faster to start. If you tried GKE Autopilot like 2 years ago, you may experience when you want to run a pod, it takes minutes, which is okay. But if you want to use this infrastructure for agents and bots, may not be that good because the user, the end user, when they interact with your web interface, and then when they ask questions, they want to see immediate response, right? So the provision time of the sandbox is also critical. And that's why we created the whole new stack to speed up the node provisioning, speed up the container provisioning. So that's available today already. Pay per pod economy. So if you're not using any pod on GKE Autopilot, you don't pay. So that's good. You only pay when your end user actually using. So not sure if I have time to show the demo. So I created something to show for demonstrating this agent sandbox. So at the right side, you can see everything's running on Kubernetes. What's that? That's the sandbox environment. Okay, so you can see there's a sandbox controller. That's from the agent sandbox SIG project, right? And then this controller, after they receive this command, they'll be able to create a sandbox. Maybe too small, sorry. Sandbox 1, sandbox 2, those are the sandbox created, right? So when user need a sandbox, we'll create this immediately. And also create sandbox policy. Basically just use it for interacting with the end user interface. In this demo, I use Gemini CRI as the end user interface. I found it quite interesting. I just need to install this what's called Gemini CRI extension. So it can now interact with the sandbox policy. The use case for this demo is this. When you use the Gemini CRI on your laptop, you can do a lot of things, right? But sometimes you may want to, have a very long running job, and you want to shut down your computer. You cannot do that with Gemini CLI. For example, if you want to use TDD to develop a features, right, and then you require a lot of testing. So this agent will take time, right? Generate code, test, fix it, and then keep it running until the test pass. So this kind of use case may not be the best on Gemini CLI if you want to shut down your computer and then come back in 2 hours. So you can use it with the sandbox. You just need to create a sandbox on your CLI extension and then issue a prompt and then let it run on the back end on the sandbox. And then when it's finished, it'll be you can come back with your switch on your computer back to the Gemini CLI section, and then you'll be able to see the response from the back end. Right, it's finished. That's the kind of the use case of that. All right. See if we can show the demo. Actually, I'll just skip it. It may be too small here. But if you're interested over here, I'm happy to show you. This is what I just walked through. actual demo using Gemini CLI extension together with the GKD Sandbox, and then you can see how we can delegate tasks to run it on the back end, come back, get the finish the result. Right. So that's the we you guys will be able to get the deck, right? I think so. So I'll have this demo also written a blog post about this idea. So yeah, you'll be able to get all these. Yeah, so happy to please take a look and then try. I open source all the demo, the proxy, the extension, and even the sandbox image. So you'll be able to interact with the sandbox using, you can actually see what browser the sandbox open. Yeah, that's quite interesting to me. So that's it. Also, yeah, thanks. Thank you, everyone. Hopefully, this
It's Q&A time now. Any questions for Derrick?
Just a little question on like when you isolate in a sandbox, how do you find the balance between the access and increasing the chances of hallucination? Like often agents want to be super helpful and can create like false ideas.
Yeah, good question. I'm not sure if I have the best answer, but I think the sandbox is actually how to reduce the hallucination, I believe, because with the sandbox, you give the agents capability of verifying what they produce. For example, I'm a developer, and then I like TDD, right? So TDD is a very good workflow to use with the agent because you not only ask the agent to generate, you ask them to verify it. And then, every model nowadays can generate, but is it work? That's the problem. So, I mean, I'm very interested in creating this closed agent loop to let the agent to validate whatever is generated by itself. And then I find it, the result, at least in the development world, is very good. If you're able to let the agent to generate the test, execute it, and then get the feedback, get the test result, you'll be able to complete the whole feature. I experiment that with different model. Some are better, some need longer time, but it works, right? When you provide them the environment, the sandbox environment, and let it complete the loop. So yeah, I don't know how to improve the hallucination, but I think providing sandbox can improve a bit. Yeah, to at least let them verify its own text or code, whatever. So in my example also, so like when generating a visual report, you also let the agent to open the browser to view the report. It will be, I would say, it will help to improve. Yeah. So because nowadays, so a lot of models they're multi-modal, right? So it is can do a lot of stuff already.
Thank you for that presentation. So it might be a bit of a naive question, but I'm trying to understand the difference between the container and a sandbox, because shouldn't the container be a sandbox already? And related to that, so we all know there's Docker has vulnerabilities. So why do you need to develop a gvisor instead of fixing the vulnerabilities as a Docker itself?
Yeah, good question. So container is isolated. However, we've seen number of vulnerabilities that the code that running in the container able to access the host kernel. Because the container world, the host kernel are shared. They are shared. So if the code in the container able to bypass this, because of some interoperability. Yeah. You can access the host kernel. That's very dangerous because every other container sharing the host kernel. So the gvisor here is basically cut the access in the user space with Golang because it's fast. And oh, sorry, I missed one point. Why Golang? Because it's memory safe. Yeah, that's another reason why we want to have a host kernel that's running on gvisor, which is not really sharing with others. Yeah, so that's the reason why I suggest gvisor for your secure agent sandbox.
Thank you.
Sorry, I just want to clarify if my understanding is correct. So basically, what gvisor is doing is that for the calls that should normally go to the kernel, which is in the container was shared by both the host machine and the host system and the container system. Now, this kernel thing is like it's emulated by gvisor. So what the calls that would go to the kernel goes to like gvisor.
Correct. Yes, that's correct.
Okay, thanks for clarifying.